All right, let's talk about one of the absolute cornerstones of Amazon Web Services, the Virtual Private Cloud, or VPC. You can think of AWS as this gigantic public digital world. It's incredibly powerful, but you're not just going to build your apps out in the open for everyone to see, right? You need your own private, secure spot.
So that's the big question, isn't it? How do you carve out that private fortress for yourself? How do you put up walls, set up some gates, and have total control over who comes in and who goes out, all while you're living inside this massive public cloud? Well, that is exactly the problem Amazon VPC was built to solve. Let's dig in.
So, at its heart, a VPC is your own little slice of the AWS cloud. The key phrases here are logically isolated and network that you define. What that really means is you get the keys to the kingdom. You are in complete control of your virtual network. You get to pick your own IP addresses, create your own subnets, and set up all the routes and gateways yourself.
To make this super simple, we're going to use one core analogy for this whole explainer. I want you to imagine the entire AWS cloud is a giant, sprawling city. A VPC, well, that's like you going out and buying your very own private plot of land right in the middle of that city. It's yours, you control it, and you get to decide exactly what you build on it and how you keep it safe.
Okay, so you've got your plot of land in the cloud. AWS basically gives you two main options to start with. The first one is the move-in ready option, something that's already built, all set up, and just waiting for you. And that is called the default VPC.
That's right. Every single new AWS account in every single region around the world comes with what you can think of as a pre-built starter home. That's your default VPC. It's designed for one thing, really: convenience. It lets you get going and start launching things like servers right away without having to get bogged down in all the networking details.
And this starter home comes fully furnished. You get a massive range of IP addresses to use, a public subnet in every single availability zone for high availability, and, this is the important part, an internet gateway. This whole setup is pre-configured so that anything you launch inside it is, by default, able to reach the internet. It's really perfect for getting your feet wet or for something simple, like a blog or a basic website.
But what happens when that starter home just isn't enough? What if your project is way more complex? Well, that's when you graduate from the pre-built model and you start drawing up your own custom blueprint. So, why on earth would you build your own VPC from the ground up?
This slide here really nails the difference. The default VPC is all about convenience and getting started fast. It is fantastic for that. But a custom VPC, that's all about control. It lets you tailor your security down to the last detail, build a network that perfectly mirrors your application's design, and really plan for scaling up in the future.
And this is where you see the real power of a custom build. You can create different layers, right? Like a public-facing layer for your web servers and a completely private, lockdown layer for your databases that can't be touched from the internet. You can split up networks by department for security, or even connect your cloud network securely back to your own office. The key takeaway here is this: a custom VPC gives you total architectural freedom.
Okay, so here's the thing. Whether you're using that default starter home or building your own custom mansion, they're all made from the same fundamental building blocks. And understanding these is absolutely key to getting good at cloud networking. Let's take a look at what they are.
Sticking with our analogy, just like any house is built with rooms, hallways, doors, and locks, every single VPC is put together using these core parts. Let's break them down one by one.
Here's our blueprint. First, we have to divide our property into different rooms. Those are our subnets. Then, we need hallways and doorways to connect all those rooms together. Those are the route tables. Of course, we need a front door to get to the outside world. That's our internet gateway. And finally, maybe most importantly, we need good, strong locks on every single door, and those are the security groups.
Okay, first up, subnets. Don't let the technical name fool you. A subnet is just a smaller chunk of your VPC's IP address range. Think of them as the individual rooms on your property. Each room or subnet exists in one single availability zone, which is great for building resilient applications. You can put your web servers in one room and your databases in a totally different one.
Now, this is a really important distinction. Not all rooms are the same. You have public rooms and private rooms. A public subnet is like a room with a big window to the outside world. It has a direct path to that internet gateway we talked about. This is where your web servers live. A private subnet, on the other hand, has no direct internet access. It's a secure interior room. This is where you keep the crown jewels, like your databases. Now, they can still get out to the internet for things like software updates, but they do it through a special kind of secure door called a NAT gateway, which is like a one-way valve. It lets them talk out, but the internet can't talk back in.
So how does traffic figure out how to get from one room to another, or how to find the front door? Well, that's the job of the route tables. A route table is basically the map of hallways and doorways for your network. It's just a set of rules that says, hey, if traffic wants to go here, send it through that door. A route table is literally what makes a public subnet public, by giving it a rule that points to the internet gateway.
And finally, security groups. If route tables are the hallways, security groups are the actual locks on the door of every single server you create. They act as a stateful virtual firewall. Now, that word stateful is really important. It just means if you let traffic in through the door, the system is smart enough to automatically let the response back out without you needing a separate rule. You can create rules that say things like only allow web traffic into this server or only let my web servers talk to my database server. They are your absolute first line of defense.
So let's wrap this all up. Getting a handle on VPCs isn't just about learning another AWS service. It's really about laying the entire foundation for everything you build in the cloud.
You know, this quote from the source material just says it all perfectly. The choices you make when you design your VPC will stick with you for a long, long time. If you do it right, you get a foundation that's strong, super secure, and can easily adapt as your needs change. Getting this part right from the very beginning is just so critical.
So the big takeaway here is that there's no single best way to do it. Should you use the default VPC or build a custom one? Well, it always comes back to what you need. Are you just spinning up a quick test server? The default is probably fine. But are you building a real production app that's going to handle sensitive data and needs to grow? Then you absolutely need to take the time to design a custom VPC.
And that really leaves us with one final question to think about. When you look at your own cloud setup, is the network just something that was thrown together to work for today? Or is it a thoughtfully designed architecture, a real foundation that's built to support where you want to go tomorrow? It's a pretty crucial question to ask yourself. Thanks so much for tuning in.